What are the challenges of computational complexity in knowledge representation? Imagine trying to solve a giant puzzle where each piece can change shape and size depending on how you look at it. That's similar to what happens in knowledge representation in artificial intelligence. As AI systems try to understand and organize information, they face some tough hurdles related to how much effort it takes to process this knowledge. Let's explore what makes this so tricky and why it matters. First up is the balance between how detailed the knowledge can be and how quickly the system can work. Some ways of representing knowledge can describe very complex ideas, but they requiring a lot of computer power to reason over. For example, simple logic might be easy for a computer to handle but can't capture all the nuances of real-world situations. On the other hand, more expressive languages can describe complex relationships but often make reasoning tasks so slow that they become practically impossible. This trade-off is a big challenge because developers need to find ways to make systems both expressive and efficient. Next, think about the size of the knowledge base. As AI systems like ChatGPT or image generators such as DALL-E or Midjourney grow, they relying on huge amounts of data and learned patterns. When trying to reason or answer questions based on this vast knowledge, the computer has to work much harder. The larger the knowledge base, the more memory and processing time it needs, sometimes causing exponential increases. This can slow down responses or even make some reasoning tasks impossible within a reasonable time frame. Handling uncertainty is another big challenge. Real-world information is often incomplete or ambiguous. For example, a statement might be true in some cases but not others, or data might be fuzzy. To manage this, systems use probabilistic or fuzzy reasoning, which adds more layers of complexity. These methods requiring extra calculations and resources, making the whole process even more demanding. Combining symbolic knowledge with machine learning adds yet another layer of difficulty. Techniques that merge logical reasoning with learned patterns, called neuro-symbolic methods, are promising but often requiring significant computational power. Managing this integration without slowing down the system is a tricky puzzle on its own. Finally, there's the concern of energy use and making sure AI systems can explain their reasoning clearly. Complex reasoning can consume a lot of energy, which is a concern for large-scale applications. Plus, when reasoning gets complicated, it becomes harder for humans to understand how the AI arrived at a decision, which is important for trust and transparency. In short, the challenge of computational complexity in knowledge representation is about making AI systems smarter without making them too slow or resource-hungry. It's about designing smarter ways to organize and reason over knowledge, balancing detail with speed, and finding new methods to handle uncertainty and large data. This ongoing effort helps AI become more capable and practical for real-world use.